related to sex-linked inheritance are located at your sex chromosomes, while your autosomal chromosomes are traits located in your autosomes. Okay, share screen ko balik. Okay, I have prepared a PowerPoint presentation for you, class. So, okay, there you go. Okay, so sex-related inheritance. So when we say sex-related inheritance class, so these are the traits that that can be found in the sex chromosomes, or it can be an autosomal trait, but the trait will appear depending if a person is male or female. Okay, so for sex-linked inheritance class, we have three types, by the way. We have your sex-linked trait. So, kanang inyong madunggan nga X-linked traits or Y-linked traits belong to sex-linked inheritance. Okay. Next, we have your sex-limited trait and your sex-influenced trait. So, these are the only topics that we are going to discuss today, and this topic was taken from your module number 14. Okay, this is the last part of non-Mendelian genetics. Okay, so sex-linked traits class. So these are traits. By the way, can you see my screen?
Yes, sir.
Okay, so these are traits that are located at the X chromosome or the Y chromosome. So mostly class X chromosome should you can always find, but yeah, mostly you can find the trait in the X chromosome if it is a sex-linked trait, because traits from the Y chromosome class, like for example, hairy ears, are very very rare to see. So yeah, and so the again. So X-linked trait are genes located in X chromosome are called X-linked. So again, class, so the traits or genes located on X chromosome are called X-linked. Genes located on the Y chromosome is called Y-linked trait. So we are not going to discuss Y-linked chromosome because Y-linked trait is very easy to understand, because you already know that a male person is the chromosome of a male person is X and Y, right? So this trait can only be transmitted from male to male, no? So kaning nga trait, Y-linked chromosome, mapasal ni siya gikan sa atong makuha rin siya nato gikan sa atong papa, kanang atong papa makuha rin nato ang trait gikan sa iyang papa po. So male to male transfer ni siya. Unlike your X chromosome, it could be or a female person can be affected, or even a male person can be affected. So sa X-linked chromosome naman, class, it's like if a mother is affected, iyahang mga anak na lalaki most likely maging affected. Okay, so that's the basic concept of X-linked chromosome. Okay, so Y-linked traits can only be expressed in males, as I have said earlier. Dili ni siya makitaan, or you cannot see Y-linked traits sa babae class because females, because females doesn't have a Y chromosome, only two X chromosome. Okay? Ang lalaki ra ang naay Y chromosome. So remember that. Okay, so for X-linked traits, so the picture that we have here on the right side is an example of a male and female chromosome. The larger chromosome is what we call the X chromosome, and the shorter one is your Y chromosome. This is the male sex chromosome, and for female sex chromosome, only siya XX. And X-linked traits are located diri sa mga X chromosome. Ano siya dira or diri karon. Okay, ano siya dira somewhere sa X chromosome. Basta X-linked traits na ara jud sa X, somewhere sa X chromosome. Okay? So, right, X chromosome are the traits that lies, the trait that lies on the X chromosome are, again, X-linked traits. So, for example, it is only, so your X-linked trait can be expressed in females in only one copy. Okay, so for example, ganito. So, we have hemophilia. Hemophilia is an X-linked recessive traits class. A X-linked recessive. So, just another information. Most of the X-linked traits are recessive kasi you can only find few traits na dominant. Yeah, most of the X-linked traits are again recessive. Okay? So an example of an X-linked trait is hemophilia. Okay. So, and it is represented by gamit letter H na gamay as a representation of the trait hemophilia. Okay. So sa babae class in females, so these are the possible phenotypic or genotypes and phenotypes in females. So if babae class, mauni ang iyahang mga possible genotypic combination. So the letter X here represents the female chromosome, and the letter Y here on the male represents the Y chromosome, and the letter H here represents the trait hemophilia. Okay, so small gamay nga H or small letter H represents the recessive allele. Okay, and the big letter H represents the dominant. So possible combination in female class. Example hemophilia is recessive, and these are the possible allelic combinations. So if XH ganyan siya class, since hemophilia is recessive, so the woman or the female person or organism will be unaffected by the trait hemophilia. Okay, if X gamay, unaffected yapang ang female will be still unaffected because she still has the dominant H or na H. Okay? If H gamay na gani, meaning homozygous recessive si female, meaning she will be affected by the trait hemophilia. Okay? So in males class, the genetic representation is different compared to males because only one recessive trait na appears sa X chromosome sa female will make a male affected by the trait hemophilia. Like for example, this one. XH dako and the Y. So you might be wondering, sir, nga nung walay Y walay H sa tapat Y? Again, because the trait is located on the X chromosome. So si Y gani sa male, disregard na nato siya basta X-linked inheritance. So ibutang naara na siya diha to emphasize that this representation of chromosome is for male. Okay? So if XH dako Y gani class unaffected si lalaki, and if XH gamay Y na gani na siya class, if inani ang genotype sa lalaki, he will be affected by the recessive allele. So again, in males, presence of a recessive allele in the X chromosome in males will make them affected by the trait. Once the trait is homozygous or once the trait is X-linked recessive. Okay? So if X-linked dominant naman ang trait, for example, hemophilia kay recessive yun na siya in reality, but example si hemophilia daw dominant nato. So if dominant naman si hemophilia, for example, if duha gani nakadako nga H, meaning si female affected, duha heterozygous female will be affected, if homozygous recessive unaffected. Na siya. So sa male naman po, if H dako gani ning presence dere, if dominant si trait, then the male will be affected. If H gamay ra gani, isa ang naa siya X chromosome, the male person will not be affected. So inana na siya class, inana na siya mag-identify sa genotype and phenotype, or sa phenotype sa X-linked, sa X-linked trait. Okay? Nay question regarding ani? Do you have any question regarding this?
Mag-Punnett square gyapon na, sir?
Yes, mag-Punnett square ta right after this, actually. So, okay, I will show you how to solve an X-linked trait using a Punnett square. Okay? Basta kung again remember this information, basta kung akong recessive si trait niya, inaani ganing mo gawas, tanawa rin ninyo per day. Okay? Once mo determine mo phenotypic o genotypic ratio. So sa Punnett square, so to solve an X-linked trait problem, so let's use this one as an example. Okay, so cross a female that is unaffected but a carrier of hemophilia and a male with hemophilia. Okay, so again, first step when constructing a Punnett square is to determine the genotype of both parents. So since again si female is unaffected but a carrier, so carrier si female now, so the female should be heterozygous, and since the male is affected with the hemophilia, so there should be a small letter H that will appear in its genotypic combination. So inani ang genotypic combination sa female, and this is the genotypic combination sa male. Nakasabot ra mo? Yun sa pagkuha. Again, si female is a carrier. So heterozygous, so XH dako, XH gamay. X gani female, kung XY male. And since male is affected, so XH gamay then Y. Again, hemophilia is a recessive, X-linked recessive trait. Okay? So in Punnett square class, inani ang mugaway. Inani ang mugawas. Okay. So sa Punnett square gani class, so libutan na to ang mga allele ni female here sa top, then ang allele ni male sa side, and then cross. So if we're going to cross X, H dako, XH gamay, so XH dako, XH gamay ang mugawas. Then if we cross both XH gamay, then the answer would be XH dako, XH gamay. Then of course, if XH dako, then Y, so mauni siya. Then if XH gamay and Y, inani ang then let's find out the genotypic ratio first. Okay, so this is the genotypic ratio, by the way, class, of this cross. So dili siya pareha sa basic na Punnett square gani if homozygous pa na siya class, homozygous gani tanan, or if homozygous na tanan, ihapon na like we are going to count all homozygous genotype inside the square in sex-linked inheritance na gani, or in an X-linked trait cross gani class. So we are going to count how many females, how many males, and of course the genotypic variations, we are also going to count that one. So the genotypic ratio in X-linked inheritance, it is not possible, dili jud na siya 100% ang answer sa genotypic ratio. Okay, ang maximum rana niya is 50%, 50%, meaning 50% sa male, 50% sa female. So dili jud na siya possible na 100% or 75% is to 25%. Dapat 50-50 ra jud na yung maximum. Okay? So sa female class, So to count the genotypic ratio, let's go first with female. So XH So XH dako and XH gamay usara man ang makita nato sa square. So 1 siya, then sa XH gamay usara man pud makita nato sa sulod sa square. So 1. Then XH dako then Y usara pud ang makita nato sa square. So kana usa. And then XH gamay then Y, or the recessed male, or the male which is affected by the trait hemophilia is also 1. So mao ni siyang genotypic ratio class. So i-count na siya nimo gihapon tagsa-tagsa, pero lahi-lahi na siya pag-count sa female, lahi pod pag-count sa male, okay? Tapos lahi pag-count sa male. So kung lahi-lahi ganon na sila sa male o female, sa female class lahi-lahi ang combination. So that's good as 1. Same pod sa male. So kung magpareha na ganin na siya class, so 2 or so may mo na siyang 2. Halimbawa sa male pareha, like for example XH dako Y na siya, so 2 na siya, okay? Pero since usa-usa naman nato nakita sa square, so that's only 1. Okay, for the phenotypic ratio naman, mao ni siyang answer. In phenotypic ratio class, what we are going to count is the affected and the unaffected children, regardless of their sex, if male ba sila or female. So, sa genotypic ratio, lahiun nato ang male ang female og count, di ba? In phenotypic ratio class, so it doesn't matter if they're male or if an individual is a male or a female, as long as he or she is affected by the trait. We are going to count how many are affected and how many will be affected and how many individuals are not affected. So in this case, since there are only 2 affected children, pangitao na to ang 2 affected. So this one can be considered as affected because this little girl has the is a homozygous has the homozygous recessive allele, and this little boy will have the recessive allele on its X or on his X chromosome. That is why he is already considered as affected. And for the unaffected, the class, so si in females, as long as there is one dominant allele present, a female person or a female individual will not be affected. And in X or in male, as long as there is again one dominant allele present on its X chromosome, then understood na siya nga unaffected. Basta recessive ang trait. Okay? Okay, so another example. Here. So the trait that we are trying to cross is color blindness. So an example of an X-linked recessive trait class. So color blindness. Okay. It's represented by letter C. So on this Punnett square, we cross a carrier mother and an unaffected father. Okay, so mauni siya mo gawa sa Punnett square class. So for the genotypic ratio, that's 25% homozygous dominant male. Female. 25% homozygous dominant female. 25% heterozygous female. 25% dominant male, and 25% recessive male for the genotypic ratio. And for the phenotypic ratio, we are going to count which the individuals that will be affected. So this individual, this and this will not be affected by the color blindness, but this one, the male, this one, since a male has the recessive allele found on its X chromosome, meaning he will be affected by the trait color blindness. Okay, and last example, we have incontinentia pigmenti. Okay, so an example of an X-linked dominant trait. So same ra gihapon nga pamaagi atong gamiton. So if we're going to cross an affected female we are going to cross affected female and unaffected male. So phenotypic and genotypic ratio. Okay, so sa genotypic ratio sa ta, so 1:1:1:1 gyapon since wala na may XR dako XR gamay sa square. Then sa male wala na may laing XR dako then Y. Then XR gamay nga wala na may laing inani sa square, and then same goes with this one. So 1:1:1:1 ang genotypic ratio, but for the phenotypic ratio class, we are going to count again the affected ones. So nai-affected diri nga sa female, nai-affected usa, nai-affected usa sa male. So that's 2. And then unaffected is 2 as well. So nai-unaffected nga usa sa female and nai-unaffected nga usa sa male. So the phenotypic ratio would be 2:2. na siya. 2:2 siya sa phenotypic, 1:1:1:1 sa genotypic ratio. Any question? May question, class?
None so far, sir.
How about the others? Mandra, okay. So, hey, by the way, class, I will be sending this PowerPoint presentation later, so that you can use this one to study. And sige, mauna to sa for now. And then, okay, so if wala na may question, let's proceed to sex-limited traits. Okay? So, sex-limited traits class. So these are sex-related inheritance, but considered as sex-related inheritance, but they are autosomal. So unlike your sex-linked or sex-linked, no, these traits, sex-linked traits can be found in either X and Y chromosome. But for sex-limited traits, so they are autosomal class. So they are not, or so these are the traits that cannot be found in the sex chromosome, so or the what we call X and Y chromosome. Okay, so mao na siya autosomal inheritance yan class. So these are traits that cannot be found in our sex chromosome. Okay, so the difference comes in the expression of genes in the phenotype of an individual. So you will know this one later on, since I have prepared a table for sex-limited traits, so that you will be able to understand what are sex-limited traits. And then these traits, matawag siya nga nung sex-related inheritance siya because it can only be expressed in one gender. So may pagka-sexist siya nga trait since this trait, for example, so since this trait appear lang siya sa puro babae, then wala ni siya sa mga lalaki na trait. Or inana ba? So inana siyang sex-limited trait. Okay, so an example of a sex-limited trait is the expression of a lactation in cattle. So in cattle gani class, so both male and female have the gene expression in of lactation, but only the female can actually lactate. So ang male di man makapatutoy og mga anak nila. It's mga anak nila, ang mga babae raman nga katol ang makapatutoy. So mao na siya ang more like the concept of sex-limited traits. So again, both male and female possess the gene pair for lactation, but it is only expressed in female. So yeah, all right. So this table represents represents sa katong explanation nga naa nato dire earlier naa nato dire. So ang pasabot sa both male and female cattle possesses the gene pair for lactation. Okay, so The gene pair for lactation is represented by the letter L. Okay. As we have observed, okay, so XX, ang XX class is represents the female, and the XY represents the male, ha. And letter L gani represents the allele for lactation. Okay. So take a look. So female has two dominant alleles, meaning female is lactating. But take a look at tanawa sa males class. Na sila'y duha ka dominant alleles. So duha ka dominant alleles. So ang standard gani if na duha ka dominant allele, meaning mo express po ni siya og lactating ang characteristic. Pero sa males gani class or sa sex-linked inheritance, bisa naa pa na siya duha ka dominant allele, basta lalaki or male, dili na sila, or the male will not possess or will not express the lactating characteristics, because again, sex limit, since this trait is only limited for females. So again, bisan unsa pa na ilang mga allele diha class, dominant, heterozygous, or recessive, as long as the trait is sex limited trait, so it is only limited to one, or this trait will only appear in one sex. Again, so si female na duha ka L na dominant, so the female will express or will manifest the lactating characteristic. Then female is heterozygous, so still female will manifest the lactating characteristic.